So again, just another reminder that the teacher explained during the lecture: causal versus non-causal systems. Should write that. So for a causal system, it's very similar to a system with memory, or like this is very similar to the memory versus memoryless system from the last video. And the way it works is the output is depending on the present or past values of the input. And for a non-causal system, the output only depends on the future values of the input. And you can see here that's pretty similar to memoryless and memory systems, where non-causal and memoryless is pretty similar, except only difference is the memoryless depends on present and the non-causal depends on future. And for a system with memory, depends on future or past values of the input. And then for causal, it depends on present or past. So if you watched the last video, this video would be a lot easier to understand. So I recommend watching the video before on how I explained it. So just to give you a reminder, if you have something like x of n minus 1 or x of n minus 2 or x of n minus 4 or something on the lines of that, or x of n minus t, then these rely on past. Anything you plug in for t will give you a past value. So now, same goes for the positive, except it's the future value. So x of n plus 1, x of n plus 10 to the x of n plus 10. So it relies on future values. And if you have something like x of n, that is present. That would be a good example of the present. Definitely recommend you watching the video before, because it explains it a lot better on how to identify it. Okay. So I just wrote these examples so I don't have to waste time in the video. So let's go over the first one. So let's say we plug in, let's say our present is 0. So let's plug in t equals 0 for all of these. So plug in t equals to 0 here, you get y of 0, and then which is equal to x of 0, but then you get x of minus 4, or 0 minus 4, which is a past value. So since we have a past value, the system is causal. For the next example, let's say n is equal to 0 here. Say n is equal to 0 for the present value. And you get y of n is equal to 0. And you get x of n, which is equal to x of 0 plus 3x of 0 plus 4. So you get x of 4. So the output depends on a future value of the input, and the input is x of n, and the output is y of n. So y of t, or y of n, is output, and the input is x of t or x of n. So knowing that the output depends on the future values of the input, which is this situation, we could say this is non-causal. Let's go over the next example. So let's say n is equal to 0 here again. Now we have n plus k. And k could be anything from minus infinity to 1. And if it's 1, then it could still be a future value. So if you get n plus 1, so the output depends on the future value of the input, which makes it non-causal. Now for the last one, it's a little tricky. We have the output, we have y of n of 0, which is equal to, and we're taking n equals to 0 in this case, x of 0, but then u of n plus 1, this will be 0, and yeah, it's a future value, but what is our input? Our input is x of n. We don't care about u of n when we're checking, because it's not our input. And that doesn't count as our input. It's u of n, not x of n. So we need to look for x of n. So we have y of n and x of n, which was the situation here. So the system is causal because the output depends on the present or past values of the input. So it's causal. And if you didn't get anything, just watch the video again, because it pretty much had everything. And yeah.